Hi there, and welcome to Lesson 8.5, Part 1. So today we're going to learn about applications of matrices and how determinants can be used for these special applications. The first application that we're going to do is for solving a matrix, and we've learned how to solve a matrix before, earlier in this chapter, but now we're going to see how determinants can be used to solve a matrix. Now remember, what does it mean to solve a matrix? Remember that matrices can be set up as a system of linear equations. So we've got a system right here. We've got the system of linear equations that just showed up. Negative 4x minus 7y equals 47, and negative x plus 6y equals a negative 27. And we could use Gauss-Jordan elimination, things like that, to solve for the variables of this linear system. Now we're going to learn a new way that's going to use determinants, and this is called Cramer's rule. So Cramer's rule sets up these fractions to solve for the variables, and we're going to learn what these variables mean here in just a second. So your x variable can be solved by setting up the fraction of a special determinant here, which is your dx determinant, divided by the determinant of your coefficients. And y can also be solved by setting up your dy matrix or determinant and dividing that by the determinant of your coefficients. Okay, so what do I mean by all these d's and dx's and dy's? Well, you're familiar with what d is. It is going to be the determinant of your coefficient matrix. So you are setting up the matrix right here without the answers, just the coefficients here. And then you have to solve for the determinant of that. So d would equal the determinant of your coefficient matrix. Okay, so we know how to do that. That means that we're going to multiply negative 4 and 6, and we're going to subtract off negative 7 times negative 1. So we get negative 24 minus 7. So that ends up giving us a determinant of negative 31. Now we need to figure out what our dx matrix is. So something changed here. It looks kind of similar. We've got the numbers from our linear system, but not quite in the same order. For your dx matrix, or whatever variable comes first, what you're going to do is you're going to swap that first column with the answers, with your solution. So instead of having, like our coefficient matrix, negative 4 and negative 1, we're going to replace that with our answers in the same order. So now we have 47 and negative 27. And this is our dx matrix because we replaced our coefficients for our x variables. Okay, so now we need to find the determinant. Same thing that we did before, cross multiply and solve. So we get 47 times 6 minus a negative 7 times a negative 27. When you simplify that out, you find out that your dx equals 93. So now that we know that dx equals 93, we can actually solve for the x variable, right? We have our equation right here. We have all the pieces of information that we need. We've got our dx and we've got our d. So x equals 93 divided by negative 31. So our value of our x variable is a negative 3. Okay, now we need to solve for our y variable. So our dy matrix is going to be set up very similarly to our dx matrix. It's just now it's going to be our y coefficients that change. So we see here our x coefficients came back. They're back in our matrix. But now it was our y coefficients that changed. So instead of having negative 7 and 6 right here, we're going to swap that with our answer. So 47 and negative 27. So now we're going to figure out the determinant here. So we get negative 4 times negative 27 minus 47 times a negative 1. That gives us 155. All right, now we can solve for our y variable. We set up our equation y equals 155 divided by negative 31, and we find that our y variable equals negative 5. So we've done it. We've solved the matrix using Cramer's rule. We've solved our linear system. Let's actually really quickly check and see if these are in fact the right answers. So if we plug these variables in to one of our linear equations, that we have up here, we should get the same value. So if we did -4 times -3 minus 7 times -5, that should equal 47. And here now we've got a positive 12 plus 35, and when we add that together, yep, we get 47. We are happy campers. It worked. And we can also see if you plugged it into the second equation, you'd get the same answer. It is in fact a solution. So we have now found the solution to our linear system using the determinants of the matrices. And so we did this with 2 different variables, but you can do this with as many different variables as possible. You're just always going to swap the variable that you're solving for with the solutions. So here we swapped our x coefficients with the solution because we were solving for our x variable, and over here we swapped our y coefficients with the solutions because we were solving for our y variables. Everything else in the matrix would stay the same as your coefficient matrix. Okay, so let's move on to the next slide. Now we're going to use determinants to find the area of a triangle. So matrices can be used to find the area of any kind of polygon. For right now, we're just going to use it for a triangle. So we are given a triangle with generic coordinates, x1, y1, x2, y2, x3, y3. To solve for the area of a triangle, we are going to have this formula right here. So what we see is that the area of the triangle equals plus or minus 1/2 times the coordinates. But we have to add a third column of 1s here to make it a 3x3 matrix. So this is your formula that you're going to use. The first set of coordinates go on the first row, second set on the second row, third set on the third row. And if you plot your coordinates and you put them in a counterclockwise manner in your matrix here, so that as you go from one point to the next, you don't have to worry about the plus or minus. The plus or minus is here only to make sure that your area is positive, because remember, we cannot have a negative area. So that's what the plus or minus is for. You're going to multiply your answer, your determinant, by a negative if you happen to get a negative answer, just to make that area positive. Okay, so let's just actually put this into use. So we need to find the area of the following triangle. First, we've got our formula. Area equals 1/2 times our matrix that we have for the area of a triangle. Now let's swap this and put in our points. So now we get the area equals this matrix. So here are 3 different points. 3, -1, that's this point right here. 7, -1, right here. And 7, 5, right here. And then remember, we have to have this last column of 1s to solve. Okay, so we can find the determinant of that matrix. That's what we need to do. Remember, these lines mean find the determinant. So you can pick any row or any column that you want. I'm going to pick the last column just because it's easy coefficients that I'm going to multiply by when I expand and find the determinant through expansion. So I'm going to use the last column. So that means that my area formula is going to be set up as 1/2 times 1 times the cofactor of that position. So cofactor of row 1, column 3, plus 1 times the cofactor of row 2, column 3, plus 1 times the cofactor of row 3, column 3. So I can get rid of those 1s and make it even easier. That's why I chose that column, to make it easy on myself. So now we've just got the area equals 1/2 of the sum of those 3 cofactors. Now we got to figure out what each of those cofactors are. Okay, so our cofactor of row 1, column 3 is going to equal 1, right? These are an even number, so that means that I multiply it by 1 instead of -1, times the minor of row 1, column 3. So find out minor of row 1, column 3. We cross out row 1, just like we did here, and column 3, and solve for the determinant. So that means that my cofactor is going to be 35, 7 times 5, minus a negative 7, which gives me 42. So my cofactor of row 1, column 3 is 42. Okay, so now let's move on to the next one. Cofactor of row 2, column 3. This is going to get multiplied by a negative. 2 plus 3 is 5. 5 is an odd number, so that means I change the sign of my minor once I get it. Okay, we got to find our minor. Let's cross out row 2, column 3, and find the determinant. So that means we have negative 1 times 15 minus a negative 7. That gives us a negative 22 when we solve that out. All right, last one. We've got cofactor of row 3, column 3. So let's cross those out. It's going to be multiplied by 1 because 3 plus 3 is 6, even, so it does not change the sign. All right, so that means we have negative 3 times a negative 1, minus a negative 7. That gives us 4. Okay, so we have everything that we need. So let's put it back into our formula. Our area now equals cofactor of 1, 3, so 42, minus 22 plus 4. That gives us 1/2 of 24. So our area, 12 square units. We have solved for the area of this triangle using the determinants of the matrix. Okay, that is it for today. I hope you guys have a wonderful rest of your day and have a good one. Take care. Bye-bye.